Hello and welcome. Today we're going to be discussing the problem it's Mooin time for. In this question, we are given a string of M's and O's that we want to print out with a twist. And this twist is that every time we type the letter O, all of the previous letters we've written so far flip. So every M becomes an O and every O becomes an M. So for example, if we wanted to print out the string moo, M-O, we would start by typing an O, which flips all previous characters, but there aren't any previous characters yet. Then we type an M. M's don't do anything special, so we just get OM. And then when we type the next O, the two previous characters flip, so the O becomes an M, the M becomes an O, and then we add our additional O at the end. When we type O again, now the previous three letters flip. When we type O again, now the previous four letters flip. And you can see that we did produce the desired sequence. And the output of the problem is this sequence of letters that we had to type in order to produce the string moo, mo. Now, the problem does mention an impossibility case. However, it turns out this impossibility case is impossible. It is always possible to produce the sequence in the input. We just need to figure out how. And we want to find some sort of greedy algorithm to do this. And the key observation that we want to make is that since the operation changes everything to the left, right? Every time I place down an O, every character that I've already written so far, so the things to the left, flip. Therefore, we want to work from right to left. We want to work backwards. And the benefit of working backwards here is that any choice made in the past won't be impacted by future choices, right? So if I work backwards and I choose what is the last character I'm going to write, that's not going to change based on any choice that I make in the future, because again, those future choices will only affect the things to the left. So let's try this example one more time, but now working backwards. And I think we can start to see how we actually came up with this particular sequence. So what we're going to keep track of is the O count. This is crucial. It keeps track of the number of O's we've typed so far, and it gives us information about whether or not I'm flipping the previous character or not. So let's take a look at the end of the string. So far, we haven't printed out any O's, so the string is unflipped. So if I want to print out an O, I should literally just write O, and that works. But now my O count is odd, so that means that every letter going forward is going to be flipped, so that if the next letter is an M, given that it's flipped, I actually want to write down an O in order to produce an M. So it's backwards because the O count is odd. But now the O count is even, right? I've typed a total of two O's, so that means all of these characters have been flipped twice. And if you flip a binary number twice, it just ends up back where it started. So therefore, if I want to write the next character, which is an O, I'm just going to type an O, right? Because this character has been flipped twice. If I flip an O twice, it'll turn into an M. When I flip it again, it turns back into an O. So I'll just write down an O. But now my O count is 3. So in order to write down this O, I'm actually going to write an M. Because the O count is odd, I want to write the opposite of the character I currently see. And then I'm going to go to the next character, and since the O count is still odd, I'm going to write the opposite of what I see. So I'm going to write down an O. And you can see that we've produced this exact sequence. O, O, O. Those are the three O's at the end. M, O. And just to highlight the algorithm concretely here, the core idea is that if the O count is even, we write the current letter. If the O count is odd, we simply write the opposite letter. And we're just looping over the string backwards as we do this. This idea of working from right to left is crucial, right? So if you try to solve this problem from left to right, it's going to be a lot more complex, if not impossible. So anytime you have an operation that is changing one half of the string, you should think about, is it easier to start from the left side of my string, or is it easier to start from the right side of my string? To give you another example of when this has happened in the past, take a look at the USACO problem balancing bacteria. I think now we're ready to jump into the program. So what we've done over here is we've just read in the input and looped over the t test cases. We're always printing out yes, because again, it's always possible to produce the string. This greedy idea will always work. If k equals 1, then we also have to print out the sequence itself. So you do actually get partial credit if you just read in t and then print out yes t times. So that can be an easy way to get some free points. But now let's take a look at the program. We've read in n and s, and we want to loop over s backwards, keeping track of the number of O's we've seen so far. So we're just going to loop from n-1 to position 0. And if the O count is odd, then I have to flip the current character in s. So the way I can do that is by checking if SI is an M, then I'm going to set it to an O. If it's not an M, then it must be an O, so I'll set it to an M. And then I simply want to check, did I type an O or not? If I did type an O, I'll increase the O count, and then I'll print out my sequence. So we get a very simple greedy algorithm as long as we get this crucial observation that we need to be working from right to left because the operation is always changing the left prefix or the left portion of the string. Thank you so much for watching, and I'll see you in the next one.